Hello, everybody. My name is Perry Correll. I'm Director of Wireless Solutions at Extreme Networking. Part of my other responsibility is actually being an interface to the IEEE, the Wi-Fi Alliance, and now even the Wireless Broadband Alliance. So as a result, we're going to talk a lot about wireless today. We're going to talk about Wi-Fi 6. We're going to talk about 5G. We're going to talk about CBRS, because these are the wireless topics everybody's talking about today. The biggest issue here is that, are they competitors? Do they just coexist or collaboration? And that's what we're going to talk about, because you read a lot of articles, you read a lot of white papers, and what you hear is that, Wi-Fi versus 5G. And it's not like a mixed martial arts. It's not like MMA. What it's really more like is WWE as far as wrestling, because it's more of a tag team. Because depending on the use case, depending on how it's deployed, depending on the environment, you might use just one of them, or they actually might all work together to optimize an overall experience. There is no one answer. There is no right way to design this, though there could be lots of wrong ways to design it. So we're going to talk about these today and hopefully educate a little bit. One of the first things I want to talk about is 5G and Wi-Fi, where they came from. Now, what's going to surprise a lot of people is they both came out of the same place. So if you see here, it says built on IMT 2020. About 8 years ago, the ITU, the International Telecommunications Union, kind of get a team together and trying to figure out what mobile telephony or telecom is going to look like in 2020. And obviously we're here now. And what they said is, okay, everything's changing. All the applications are going to mobile. So there's going to be a lot more traffic. The applications are going to need more latency. You're going to have human-centric communication, people to people, or machine to machine, or both. You're going to have huge density of users, high quality, and had to maintain high quality for mobility. And it's not just voice, but it's multimedia also. So a lot of things happen. And so they both actually started developing for this. On the licensed wireless side, the communication side, this is where we came to 5G. On the unlicensed, and back then we were still talking 11N, maybe a little AC, but this was what became 11AX. So once again, this was an evolution on both sides of the house, and you're going to see how they both evolved and how they actually can support each other going forward, which is probably the most important part. So I'm going to start with Wi-Fi 6 first, because that's what I think is probably the most interesting to people right now, because everybody knows about it. You got your phone now, and you can actually look in there, and depending on which phone you have, it'll actually say what version of Wi-Fi you have. Prior to this, you would just get a symbol that shows Wi-Fi, and you don't know if it was 11AB or Wi-Fi 6 or whatever. So now you actually have some idea of the quality of your Wi-Fi, very similar to what cellular always did, or has done for a long, long time. The key point to understand about Wi-Fi is that Wi-Fi continues to evolve. If you go back to the very beginning, which it's 20, 23 years old right now as far as Wi-Fi, it's actually a mature technology, and it's evolved over time. One of the problems us as an industry have done is we've actually kind of a little bit boy cried wolf, because about every 18 or 24 months, a vendor will come to the customer and say, hey, I got this brand new wireless technology. It's going to fix all your problems and save everything and high performance and all this. And it was 11G and 11A and 11N 150 and 11N 300 and 11N 450 and 11AC wave 1, 11AC wave 2. And this is how it continued to evolve. And every one of those technologies got faster and faster and faster, as you can see here. What happened now is when Wi-Fi 6 came out, when 11AX came out, we came and said the exact same thing. And many customers and partners are sitting back saying, yep, heard that before. Nothing new here. So why should I worry about it? It's important to understand that Wi-Fi 6 is actually different. Yeah, I know you've heard that before. But prior to this, all the Wi-Fi technologies pretty much work the same. And the way they worked is that only one person can talk at a time. So if I've got 10, 20, 30, 100 devices connected to an access point, connected to a radio, even though all those devices are connected, only one gets to talk at a time. And that's a key differentiator. With 11AX, with Wi-Fi 6, it added multi-user capabilities. So now I can actually talk to 3, 4, 5, 10, a dozen or so devices simultaneously. So that's why Wi-Fi 6 has talked about efficiency and not just performance. Yeah, it is a little bit faster, but the huge value is the efficiency part of it and not necessarily the performance. The other thing to understand too is Wi-Fi 6 is not the end. We're already talking about Wi-Fi 6 with 6 gigahertz. And next, we're even talking about Wi-Fi 7. You can actually go Google Wi-Fi 7 now and come up with 11BE. So it's a continual evolution that's never going to stop, and it's important to understand that and important to appreciate that. So here's what we got. Now, the IEEE writes standards. 802.11ax is the latest standard. The Wi-Fi Alliance, on the other hand, they verify interoperability with their certifications. Now they're calling the 11ax certification Wi-Fi 6. So that's the difference. They typically mean the same thing for most of us, but 11ax is like the 750-page standard, whereas Wi-Fi 6 is about a 150-page certification that makes sure different vendors' products work together. The key value props of 11ax, the key one is something called OFDMA, orthogonal frequency division with multiple access. Yeah, it sounds like a big word. You sound very smart when you do it. But this is the multi-user type functionality that really separates Wi-Fi 6 from everything else. One of the important things to understand, important things to appreciate, is a lot of times when people look at Wi-Fi 6 saying, you know, I don't want to be on the bleeding edge. I don't want to be the first one that gets out there. One of the interesting points about Wi-Fi 6 is none of these features, OFDMA, MIMO, multi-user MIMO, OBSS, TWT, and all that stuff, none of this stuff is new. OFDMA actually goes back to WiMAX, goes back to the 2007 days. What happens is with 11ax, with Wi-Fi 6, we actually integrated a lot of wireless technology that might have been used in other wireless things into Wi-Fi. So it's not brand new. You don't really have to worry if it's going to work or not. It's been around for a long, long time. So the biggest thing, though, as I said, is OFDMA, orthogonal frequency division multiple access. Now, why do I say that's important? It's important because we need to understand the way Wi-Fi has always worked. And I kind of mentioned this a little while ago. Wi-Fi, even though I've got a bunch of people connected, I only get to talk to one person at a time. So if you look at this screen, I'll talk to the tablet, then I'll talk to a phone, and I'll talk and I get an acknowledgement, and I got to talk and I get an acknowledgement, and I got to talk and get an acknowledgement. And over the last 20 years, what they did with 11A, B, G, N, and AC is they talked faster and faster and faster. But I was still only having one device talk at a time. So that was the challenge with Wi-Fi, is that how can I allow multiple users to talk simultaneously? And this kind of like, if you've been in this industry long enough like I have, it's kind of like when we went from, you know, hubs in switching or hubs to switching with wired Ethernet. And I'm not going to call this wireless switching because people freak out when you actually do that, but it allows me to talk to multiple people at one time. So how does that allow to do that? It's important to understand how the layer one, how the wireless works. If I've got this wireless channel, let's just say it's a 20 megahertz channel versus a 40 or you know, an 80 or whatever it be, is that channel is not a single channel, it's multiple sub-channels. And with prior technologies, one user would use all those sub-channels. Now you're probably trying to get an idea what I'm talking about here. With 11ax, with Wi-Fi 6, what we're able to do now is saying, I'm going to take all those sub-channels and I'm going to split them up. And I'm going to split them up into something I call resource units. And now instead of giving all those resources to one client, which I can still do, I can break it up. I could say, you know, I can have 9 people talking at one time. They get much less bandwidth. But think about voice. Think about a nurse call system. Voice does not need a lot of bandwidth. They just want consistent access. So I can split it up and allow me to talk to 9 people at one time. Or I can split it up into chunks of 4 or chunks of 2 or chunks of, or mix it any way I want. I can have one user getting, you know, half the channel and then split up the other half channel between 4 or 5 users. And every time I transmit, I have this same capability. This is what separates it apart. And it's very, very important to understand that. Once again, we did this to ourselves because every year we said the new Wi-Fi is better. But this is actually something special, and it is different. It allows true multi-user communication, uplink and downlink. For what happens now, the AP is in charge. The AP decides who I'm going to talk to. It also decides who's allowed to talk to me. So if we look at this kind of a different way, the first transmit opportunity, the AP can say, I'm going to talk to 2 devices. Or 2 devices can talk to me. The next transmit opportunity, maybe I'll talk to 4 people or 4 devices. The next, hey, somebody needs a big chunk of data, so I'm going to give them all the bandwidth, all the resource units. The next time I can talk to 2, the next time I can talk to 1, the next, once again, every opportunity, every transmit opportunity, I can go back and forth, which means I don't have to rely on QoS. QoS relies on, I'm going to prioritize one user over the other. Now I can allow them both to talk at one time. And that separates it. And I can't emphasize this enough, how different 11ax is, Wi-Fi 6 is, versus the previous units. So looking at the scene that we saw before where everybody talked one at a time, now it's different. Now I talk to everybody simultaneously. That's the efficiency part. That's what separates it. And Once again, I can't emphasize enough how important this is and how much it changed. We went from 11AC to 11AX or Wi-Fi 5 to Wi-Fi 6, whichever way you want to look at it. That's the value going forward. So what's happening now? This is kind of a little bit of an eye chart, but obviously you can get the presentation and look in a little bit. But like what happened with Wi-Fi 4, Wi-Fi 5, Wi-Fi 6, and now we're all talking about 6E. 6E is Wi-Fi 6 operating in the 6 gigahertz band. Now, most of you have heard that the FCC and Europe, they've opened up a lot more spectrum. Depending on where you are in the world, you have different levels of spectrum. But in North America, theoretically, we're going to get, right now, we've only got between 2.4 and 5. We've got about 27 available channels, but if you consider DFS, which limits the amount of channels I can use, I might only have about 12 or 15 usable channels. What Wi-Fi 6 gives me, or the 6 gigahertz space in Wi-Fi 6, it gives me an extra almost 60 channels. Once again, I'm not, a lot of people say we double the amount of spectrum. We're not. We're actually quadrupling the amount of usable spectrum, which is more important. So obviously I got a lot more bandwidth, a lot more capacity. Channel planning is much, much easier. Obviously it works in the 6 gigahertz band. It supports the other functionality. Has higher levels of security. The one thing to be aware of is that on the radio itself, so a 6 gigahertz radio, all I'm allowed to talk to is Wi-Fi 6 clients on 6 gigahertz. So it's going to be a much, much cleaner spectrum. On the access point itself, it'll allow me actually to go and talk to the 2.4 clients and the 5 gigahertz clients. But that 1.6 gigahertz radio, I can actually have multiple communications, and every device is going to have to be 6 gigahertz. So obviously it's going to be very, very high performance, high throughput, much more efficient type environment. So once again, definitely something what we're looking for. So what's the value proposition associated with this? Obviously, optimized traffic management, improved security, higher capacity, increased client capacity, improved performance. What's I mean? All the good things. And if you want to know a lot more, obviously go to our website or go to this link here. We did a great Wi-Fi 6 for dummies. It's not for dummies. It's actually pretty intelligent type stuff here. So take advantage of it, give you a great idea of what's happening with Wi-Fi 6, and give you a little bit about what's happening with 6E. So that's the key point going forward. So let's go to the next one, 5G. As I said before, they both evolved out of the same place. They both evolved out of that IMT 2020 type functionality. It's very important to appreciate that. Also, just like with the screen I showed you before, that Wi-Fi, it's not a revolutionary thing, it's an evolutionary thing, even though you could actually say Wi-Fi 6 was a little bit revolutionary. Same things happen with cellular technology. Once again, depending on how long you've been involved in this industry, 1G, 2G, 3G, 4G, 5G. And I hate to tell this you right now, but if you can go, you can Google right now, you can go 6G. They're already looking, just so like we're looking at Wi-Fi 7, they're already looking at the next generation of cellular, because that's the way it works. And it kind of sees how we grew over the years, and what 5G is about is supporting everything. Basically, worldwide wireless web. I can get to anything via cellular type communication. That's the goal. That's what they were targeting. Once again, just like Wi-Fi was targeting to support all these technologies, 5G is also targeting to do the exact same type functionality. So where it came from, global mobile communication system, 3G, PPP, ITU, IETF, WBA, they're all involved in it. Important thing to understand is when it will be available. This varies greatly by region, by the carrier, by the device. And just because you've got a phone or you've got a device that says, I support 5G, doesn't mean it supports all the functionalities of 5G. It will evolve. And just like, as I mentioned at the very beginning, 10 to 100 times faster, greater density of billions of devices, extremely low latency, reduction in energy network usage, and it's two primary functions. It's got what's called new radio, and it's got what's called network slicing. And we'll talk about that because it's very important to understand and appreciate that going forward. New radio technology, and what that means is I want to use more spectrum. I don't want to say that cellular communication, I get this and the rest is unavailable. So the new radio interface is going to have the licensed spectrum. It's going to have shared spectrum, and it's going to have the unlicensed spectrum. So when you're looking at comparing 5G to Wi-Fi, they're not actually competing with each other. Actually, wireless is going to be Wi-Fi is actually going to be an on-ramp into the 5G space, and it's very important to understand that. And once again, depending on how it's deployed, depending on your region, depending on the functionality, depending on the carrier, you'll have different levels of capability in here. But the whole idea of 5G is to take advantage of everything, licensed, unlicensed, and even shared spectrum like CBRS, which I'll talk about in a little bit more. The other thing that's often forgot about when you're talking about 5G is something called network slicing, which is the back end of 5G, which is really, really cool. The idea behind this is on the back end, I can take different use cases, different markets, different solutions, different verticals, and give them dedicated resources. And it's not just bandwidth. It's not just QoS. It's not just latency. It's also I can dedicate them certain amounts of performance and maybe more importantly, a certain amount of compute power within that environment. So 5G, everybody talks about the radios and the higher performance and the higher throughput, but this is just as important. And as you can see along the bottom, all types of wireless interfaces will tie into this whole functionality. So it's not going to be one or the other. They're all going to tie together. They're all going to work together. And that's very, very important to understand and also very, very important to appreciate. So summarizing it, once again, it's always about performance, capacity, and latency. 5G applications, the whole idea is that if I can guarantee 1 millisecond latency or whatever, if that was possible, because that's what they were targeting, can I build applications to take advantage of that? And do applications actually need that? Just because I can build something that'll operate at 1 millisecond of latency, is 2 or 3 or 4 milliseconds good enough? So that's where you get into this debate of, what's good enough and do I actually need this? Some use cases, the answer is going to be yes. Others, it's going to be yes or no. Virtualization of the core network, that's that network slicing. Efficient scalability, once again, it's designed to go to a billion devices, and a flexible network architecture. I'm not tied to these channels or the low band or the mid band or the high band. The whole idea is, why can't we suck them all in? Wireless is wireless. And as I said at the very beginning, the average user doesn't care. They don't care if they're connected with WiMAX. All they want to do is work. Use cases are pretty much anything. Virtual reality, augmented reality, smart city, automotive wearables, obviously, auto-driven cars, remote cars and stuff. You're looking at using Wi-Fi and cellular as how to communicate and keep contact with other devices around them. So very, very important to understand, very important to appreciate. The last one I'm going to talk about is CBRS, and it's actually kind of part of the 5G. CBRS, Citizen Band Radio Service. When I first started hearing about it, I'm thinking, wow, CB radios, this is back to, Smokey and the Bandit in the 70s and stuff. No, it's a little bit different than that. The whole idea is it's a shared spectrum, and that's really what it's designed to do. So now you're actually going to look on your phone, and you might actually see like an ON, which is the certification for CBRS, and you've got devices that do support it. And that's important to understand, that there's devices out there that do support Wi-Fi 6. There's devices out there that do support 5G, and there are devices out there that do support CBRS, and there's also lots that don't. So it's a continual evolution, and let's just be honest, the next time you update your phone, it'll probably support 5G and maybe CBRS. Definitely the one after that will. So just be aware of that going forward. Once again, just like Wi-Fi, which is the unlicensed spectrum, just like 5G, which is a licensed spectrum, shared spectrums continues to evolve too. There's a lot of things going on out there. You might have heard of LSA, licensed shared access, or LTEU, or LLA, or multi-fire and web. Lots of technologists saying, there's a belief out there that we're running out of wireless spectrum. There's another belief out there saying we got plenty of spectrum, we're just not using it smart enough. And that's probably very important to understand and very, very important to appreciate. I kind of go along with the last one, is that, and maybe it's a little bit of both. Maybe it's always good to have more spectrum, but actually maybe we need to be a little bit smarter with it. So what's CBRS about? Basically the standards, the FCC authorized it. You got an organization called WinForum and CBRS Alliance that kind of does certification. It's 150 megahertz of spectrum. It's not a lot. That's available in the mid-band, about 3.5 space. Same radio interface as LTE. It's really designed for in-building small cellular Wi-Fi wireless. So it's like if you go to your favorite restaurant, and sometimes indoors the cellular signal is terrible. So unless they have Wi-Fi, you're not going to get much of a signal. So what they might do is they actually might put CBRS into that facility, or maybe into a hotel, or maybe into a hospital, which essentially gives you cellular communication or improves cellular communication inside the building. No restrictions of using the 3.5 gigahertz or 5G service, so they actually tie together very, very well. And it's reduced cost and deployment. I'm deploying this little access point looking thing inside my building versus asking my carrier to put up another tower closer. Obviously, that would be a huge challenge to try to do that. So obviously, it works together. They're a combination of all this type functionality to do this. And as we move forward here, this is kind of what the network looks like. And there's actually 3 different users of this. You've got incumbent users. Those are the higher priority. Obviously, the military, fixed satellite uplink, they're grandfathered in. They've got license on certain channels in certain areas that you're not going to interfere with them. The next, you've got a licensed primary access type functionality. And there's an auction going on for those licensings right now. And pretty much what they're looking at is they're going to license these channels, separate licenses within every county. So you've got counties looking to purchase licenses. You've got businesses looking to purchase licenses. You have school districts looking to purchase licenses. And then the final thing, you've got a general authentication, general access, and that's for the rest of us. So obviously, depending on the environment you're in, you have to consult a database if you're going to use CBRS. And that database is called the Spectrum Access System. And what that does is if I'm setting up my own private LTE, my own private CBRS solution, I'd go out and I'd check that database and I have to tell it where I'm actually located. And it would look if anybody with a higher priority than me, obviously an incumbent user or somebody with a license, already has those channels, in which case I can't use it. But then hopefully they'll find channels that I can use in that environment. So once again, I got to consult that. I think I consult that on every 30 days or whatever it happens, because it doesn't change a lot. It's not like they put a brand new satellite uplink every 12 hours or whatever. And so I get that. And then what it allows me is kind of a private LAN type of environment. Obviously, I got my device, as long as it supports CBRS, I will talk to that node. And once again, that node it could look very similar to an AP. It could be tied in with an AP or whatever, but it gives me that functionality, it gives me that capability, which is very, very important to understand, very, very important to appreciate. CBS infrastructure, once again, the devices are starting to appear. Once again, there's devices out there that actually support them today. But you're actually going to see a lot more with 2021. There's a big belief that the license auction going on right now is very, very successful, and obviously that proves that there's a lot of interest in here. So there's going to be environments, obviously, where this is definitely one. I want the cellular communication. I want maybe a higher level of reliability, a higher or a lower latency associated with that. So once it's about. So the value proposition, I combine the advantages of licensed and unlicensed. It's shared license. So once again, I don't have to spend huge amounts of money to get a license unless I want that license. Combines public and private wireless infrastructure. Boost indoor coverage, as I said before, in environments where I need cellular communication that for whatever reason, regulatory beliefs or whatever, that I don't think typical Wi-Fi is good enough. Whether that's right or wrong is a totally different question. I want cellular indoors. So it's much, much easier to bring that in and deploy. Once again, I become dependent on the device to support it at that point. So once again, there are some environments that really like that. There are manufacturing environments that like that. There are healthcare hospitals that might want to do that type stuff. It's ready for commercial deployments. It's out there right now. It's 150 megahertz. It's not a lot. So once again, if you kind of compare it to what's available in the whole 5G spectrum, or compare it even to Wi-Fi now in the 2.4, the 5 or 6 gigahertz space, but it actually gives you a priority level, so it's not 100% competitive. Use cases are going to be anything anybody wants to do. You know, it's very, very easy for Wi-Fi vendors to say, this is where Wi-Fi is best, and this is where CBRS doesn't work. So it's important to understand and appreciate that everybody kind of has a different idea, different functionality as far as how they believe. So how does this all come back together? How does this all work? So whether I'm talking about CBRS, whether I'm talking about 5G in general, or I'm talking about Wi-Fi, how do they play together? Are they really competitors? Do they just support each other? Do they give us different functionalities? There is no perfect wireless technology for all cases, no matter what anybody said. I've been in this industry for the wireless industry and networking for probably close to 30 years, and RF even goes back further. And if I knew better, I'd invest better. But you just never know, because if you look at what's out there right now, we're talking about 5G, we're talking about CBRS, we're talking about Wi-Fi. We're also talking about Z-Wave, Zigbee, BLE, Bluetooth, ultra-wideband. There's a lot of different wireless technologies. And if a vendor is making a product to fit in there, obviously they're going to be a huge advocate of that product. Be aware, each technology has advantages and disadvantages. So I can read white papers and say, okay, for 5G, these are all the things it does better than Wi-Fi. So obviously I should pick 5G, right? Well, maybe not. What are you trying to do? What are you trying to accomplish? What level of service do you need? And will Wi-Fi meet that requirement? And if the answer is yes, chances are you've already got Wi-Fi there. If the answer is no, then you're probably going to have to do something. You're going to have to add CBRS. You're going to have to add maybe 5G type services. But there's a 99.99% chance you are not going to get rid of Wi-Fi, because Wi-Fi is the default. Right now, there's about, give or take data, there's about 13 to 15 billion Wi-Fi devices out there today. They're estimating by 2025, there'll be about 1.5 billion 5G devices. So it's not going to replace it anytime soon. Once again, your phone that you have now, your next phone, definitely the next phone will support 5G, but your tablet doesn't. Your laptop doesn't. Your wireless printer in the office and at home doesn't. Your smart TV doesn't. So once again, there's not going to be a whole rip and replace to move to 5G. They're going to coexist. Each technology has unique use cases. Once again, I'm really concerned with latency in a medical environment. I might go CBRS for that. But I'm also doing very high bandwidth DICOM applications for digital MRIs and stuff like that. I'm probably going to use Wi-Fi for pure bandwidth. So there is no perfect one at what works for you. No technology will replace the other because there is such a thing as good enough. And that's very important to understand. It's very important to appreciate. Wi-Fi 6, 5G, CBRS, they're going to coexist. You're going to have environments that are just Wi-Fi 6. You're going to have environments that are Wi-Fi 6 and 5G. You're going to have environments that are Wi-Fi 6 and CBRS, and you're going to have environments that are Wi-Fi 6, 5G, and CBRS, and they're all going to coexist, and they're going to support each other. That's the biggest thing I can say, because if you look at organizations that even those that do actually have a dog in the fight, the Wi-Fi Alliance, obviously they got the name Wi-Fi in them, very supportive of collaboration between these technologies. They support it 100%. On the other side, kind of the carrier side of the house, you got the Wireless Broadband Alliance, kind of more on the license side, but they're also fully embrace this stuff. So the only place you end up seeing people saying that 5G will replace Wi-Fi is people that are committed to that architecture. And it's very important to understand that and appreciate that when you're talking to somebody. Wi-Fi is not going away. Once again, 15 billion devices, not going to happen. So once again, if I knew differently, I would invest better, but you're not going to have to worry about it because it is really what it is. So what that does, it kind of wraps this whole thing up. As I said, my job is to focus on wireless solutions. There is no single, this is the best way to go. You have to go this way or else you're going to fail. Important to understand, and I said this at the very beginning, I'll finish up there. There is no right way to design a network, but there's lots of wrong ways. It depends on what you're trying to accomplish. It depends on what you're trying to do. So take advantage of it. Talk to people who know. Don't talk to people that are committed to one and the other, and it'll give you the best solution. That being said, thank you for listening to me today. Hopefully this was helpful. And please reach out to me or reach out to Extreme if we can be more helpful along any one of these architectures, these wireless technologies. Thank you very much.